The objective for the experiment first one is seasonal variation in water hardness. The objective focus on comparing the changes in the water hardness of Ami River during the summer, rainy and winter season. Seasonal variation can significantly influence water quality due to change in rainfall, temperature, and evaporation rate and the river flow. During the summer season, higher evaporation and reduced water flow may increase the concentration of calcium and magnesium. Secondly, the spatial variation among sampling locations. The objective aims to evaluate the spatial difference in water hardness among the four selected sites within the Kedah Sector 30 industrial area. Each sampling location may experience different level of industrial discharge, domestic wastewater input and geolocation influence, which can affect the concentration of hardness causing ions in river. The third objective is determination of the total hardness of Ami River water is through the determination of the total hardness in the Ami River at the selected site. By using a standard analytical method, total hardness mainly represents the combined concentration of calcium and magnesium ion present in water. Measuring total hardness provides a direct indicator of water suitable for domestic, industrial, and agriculture use. I'm going to explain more detail about the introduction for this experiment. Water hardness and its main causes. Water hardness is primarily caused by the presence of dissolved calcium Ca+ and the magnesium Mg2+ ions in the water. These ions usually enter the water when it flows throughout the rock, such as limestone, karst, or gemstones. As the water dissolves these minerals, the concentration of the calcium and magnesium increase in the resulting hard water. For effective of the excessive water hardness, it can negatively affect several sectors, including human health, domestic activity, agriculture, and industrial process. In domestic use, hard water makes washing and cleaning less effective. It can interfere with soil structure and reduce nutrient availability. Therefore, it also can problem caused by the hard water in daily use. Hard water reduces the ability of soap and detergent to form leather because the calcium and magnesium ions react with the soap to form insoluble compound. This will lead to higher soap consumption and poor cleaning efficiency. Due to measurement of the water hardness using EDTA titration, this method is widely used to determine total water hardness. EDTA acts as the chelating agent that binds specifically with calcium and magnesium ions present in the water sample. This method provides accurate and reproducible results, making it suitable for laboratory analysis of water quality. For the application for this experiment, one of the applications is the water treatment purity. Since the most Ami River are hard or very hard, authorities should focus on the water softening methods such as ion exchange, alum treatment, or boiling to make water safer for domestic and industrial use. Secondly, industrial potential control, also in the application for this experiment, by identifying calcium-based industrial influence as the main source of the hardness allow factories to treat their water waste before discharge, to helping to reduce scaling problem and to meet water quality standard. Therefore, the link between the hard water and health issues support due need for the public advisor and the promotion of the treated and the softened water to reduce potential risks. Last but not least, seasonal hardness data helps authorities monitor water quality regularly, detect pollution early, and enforce environmental regulation more effectively.
Okay, next I will explain the contribution of water river. So for this research, contribute to environmental and water quality studies in several important ways. First, it provides river data on river water hardness collected from an industrial area, which help us understand the actual condition of the river. In addition, the study demonstrates seasonal variation in total hardness caused by industrial influence and natural dilution processes. The research also highlights the environmental impact of untreated industrial discharge on river water quality. Finally, it raised awareness about the potential risk of using hot water for domestic, agricultural and industrial purpose. And overall, the study concludes that the most river water sample exceeded standard hardness limits, indicating serious environmental concerns and the need for effective pollution control. So for the theory, the total hardness of water is defined as the combined concentration of calcium and magnesium ion, and is commonly expressed in milligram per liter as calcium carbonate. So in simple terms, the total hardness is represented as the sum of calcium ion and magnesium ion, and written as total hardness equal to Ca2 plus Mg2 plus. So the determination of total hardness is based on the principle of complex metric titration. In this method, EDTA acts as a hesidented ligand and form a stable 1-to-1 complex with calcium and magnesium ion. So the titration is carried out at a buffer pH of around 10 to ensure effective complex formation. Adrochrome black tea is used as an indicator, which initially forms a wine-red complex with metal ion, and at the endpoint, as the titration, EDTA binds all the metal ion and causing the indicator color to change from white to red to blue. So the volume of EDTA is then used to calculate the total hardness of the water sample.
This slide shows the apparatus used in this study, which are divided into water sampling equipment and titration equipment. For water sampling, a clean 1000 ml polyethylene bottles were used. These bottles were washed with detergent, rinsed with distilled water, and air dry. Label and cooler or storage rug were also used to safely transport the samples from the field to the laboratory. For the titration process, several laboratory apparatus were used. These include burette, a 300 ml conical flask, and a graduated pipette or measuring cylinder. Aerochromic black tea indicator, buffer solution, and standardized EDTA solution were used during the titration to determine water hardness. In addition, a stand, clamp, and burette holder, as well as distilled water, were used to ensure accurate and reliable results. This slide shows the methodology used for water sample collection. First, a total of 48 water samples were collected from 4 different sites along the Jeddah Sector 13 stretch of the Ami River. The sampling was conducted during 3 different seasons, which are summer, rainy, and winter, with 16 samples collected per season. The water samples were collected using 1000 ml polyethylene bottles, and before use the bottle, all the bottles were washed with detergent, rinsed with distilled water, and air dried to prevent contamination. After the collection, the samples were immediately stored in an ice-filled cooler and transported to the laboratory or field station for analysis. It is important to note that no filtration or pre-treatment was applied before the total hardness analysis, which was carried out using the APHA standard method. And the sampling location includes Site 1 near Ramila Samiti, Site 2 at Sam Rahwa Baba Mandir, Site 3 which is 200 meters upstream, and Site 4 which is 200 meters downstream of the river. This video shows how the water sample was collected. This slide explains the methodology used to determine total hardness of river water using EDTA complexisometric titration. First, 25 ml of river water sample was measured accurately using a measuring cylinder and transferred into 300 ml conical flask. Next, 2 ml buffer solution at pH 10 was added using a pipette. This step is really important because EDTA forms stable complexes with calcium and magnesium ion only at pH 10. Then, 2 drops of EBT indicator were added and the solution turned white wine red, indicating the presence of calcium and magnesium ion in the sample. The burette was filled with standard EDTA solution and the sample was titrated slowly. During titration, EDTA bind with calcium and magnesium ion more strongly than the indicator. At the endpoint, the color changed from wine red to blue. This slide explains the methodology used to determine total. This slide shows the result of total hardness analysis of Ami river water determined using EDTA complexisometric titration, including the reaction mechanism, seasonal variation, and hardness classification. The first photo shows the photographic illustrate the mechanism of complexisometric titration using EDTA and EBT indicator. Initially, calcium and magnesium ion in hard water form a wine red complex with EBT. When EDTA is added using a titration method, it proficiently binds with Ca2+ and Mg2+, release the indicator and cause a color change from white red to steel blue, which indicate the endpoint. The second picture shows the table present the mean plus minus standard deviation of total hardness values for different season and sampling site, and compare them with USGS hardness classification and BIS standard. All recorded values are above the BIS permissible limit of 300 mg per liter as CaCO3, indicating that the river water is safely hard in all season. And the more sample fall under the hard category with a small percentage classified as a very hard, especially during summer. The third picture show the line graph show the seasonal fluctuation of total hardness at 4 sampling sites along the Ami River. The line graphs show the summer highest hardness due to lower water level and higher evaporation. Raining season, relatively lower hardness due to dilution by rainfall. And winter, moderate hardness, stable flow with less dilution. And this line graph show the seasonal influence on water quality. And last picture show the hardness values varied with season. For summer, 300 to 95 to 400 to 61 mg per liter. For rainy, 402 to 454 mg per liter. And winter, 391 to 428 mg per liter. And these values confirm that the river remain hard throughout the year.
The conclusion, the Ami River has a very hard water, with the most samples showing hardness level higher than the safety limit set by BIS. The hardness value range from 397 to 475 mg CaCO3 per liter and are mainly caused by untreated undersoil waste that contain calcium compound. This hard water can lead to health problems such as skin irritation and high blood pressure, and it also causes practical issues like pipe blockage, damage to application, and higher household expenses. To reduce this problem, proper treatment of the industrial waste, regular water quality monitoring, and the use of the water softening method are strongly recommended. Thank you.